Hello everyone and thanks for joining. This is Sanjit. In this tech talk, you will see how to address a query performance issue in Pure Data Analytics. Performance is a key factor to PDA users, but when a slowness occurs, it's a challenge to find out root cause of the performance problem. Here, we will go over some commands that can help you to determine the problem. You will also see some tools. Those can be used to collect diagnostic data to address performance problem. When pursuing a performance issue, it's best to start with some basic questions. This steps generally doesn't take long, but don't rush through it. A simple mistake in the initial phase can put you on the wrong direction. It is very important to understand what's actually running slow. Is it a single or multiple queries running slow, or it's an overall system slowness? Depend on it, you can direct your investigation. Knowing the exact time of the performance problem will help you to focus on the section of the diagnostic data. Otherwise, you will hunt through the haystack. If the problem is currently occurring, it will give you an opportunity to diagnose it on the fly, which leaves less chances to misdiagnose a problem. If a query taking longer, first thing to check what it's doing. Is it running or waiting? In case of a wait state, it may not be the actual issue. You need to check what are other queries running. Most probably it's the running queries that consumes resource and cause of other queries to wait. If there is a long running queries, you need to confirm if it is normal behavior. Long running queries are often the number one cause of overall performance problem. When the last time routine administrative activities like backup, groom, generate statistics ran? By any chance any of those activities missed recently? An outstanding groom or a missing table statistics can cause poor performance. If the performance problem reported by some users, are they part of same resource group? If yes, then it's an indication of a resource constraint related to that group. Is there indication of any hardware issue? It's better to address hardware issues first because those can impact overall performance problem. All this information are important factors that can contribute to your current problem and you should not overlook them. A very common question you should ask: what has been changed recently in the system? Changes can be related to hardware, software, data volume, system load, or configuration settings. A small changes in one of these areas can negatively impact the performance. So try to find out any recent changes before start digging. There are many reasons a query can run slow. Just like software issue, a bad hardware component can cause query to run slow. Here are a few common indications that can help you to identify if it's a hardware or software related problem. These are not a foolproof plan, but this can give you a basic starting point to investigate a query performance issue. Starting point to investigate a performance problem should be run health checks. There are two scripts available to check hardware and software health of your system. Run NZ Health Check tool to check the hardware issues. Look for any disk, memory, SPU, or network related issues reported. If you have a hardware issue, it may or may not be directly related to your problem, but you should address any hardware issues first. You never know how it can impact the overall appliance's health. Similarly, run NZ Health script to check the software side. It runs several NZ commands to verify health of your system. It captures many variable information. Most common areas you need to check are listed in this slide. Again, these may not be directly related to your current issue, but most of the time it can give you a good starting point. We will discuss some of this NZ commands output in the later slides. Let's start with what to do if there is a long running query. Any query other than load and unload jobs that have been running for a long time. means it must have utilizing a lot of resource on the system and causing others to slow down. There are different ways to find out long-running queries. You can use ng-session command to check the start time to find out any queries running long. Next, use the ng-sqa progress to use the resource used by the corresponding plan. In general, you will see a large resource used by the long-running query. You should try to understand why this query is running long. Few things to look here: any outdated statistics on the table involved, storage or processing skew occurring, any version table exist. If it is a new query, it may need some kind of tuning to run it efficiently. You can utilize ng query stat scripts to get daily statistics from query history database. This usually helps to understand what type of workload queries run on the system and if anything is different than previous days. Are there any long-running loads or unloads jobs? If there are too many long loads and unloads job running, it will cause other jobs to queuing up and appear system hang. Check the ng-skew output for any load unload jobs are running. Do they have high null IO? Typically, a null IO indicates load or unload operation is waiting for external IO operation. You need to check the network interface and any possible issues at the client side first. Just like the previous slide, use the ng-sqa progress to verify resource consumed by individual load unload job. You can also check VT load stat table to see if loads are at all moving, such as byte processing, rows inserted, etc. Other than null IO situation, common way to reduce performance issue due to long-running load-unload job by reducing the number of concurrency within the load and unload operation. And you can create a scheduled rules to limit maximum number of loads or unloads can run at a given time. Data distribution and performance are interrelated. A storage skew is the result of bad distribution. In PDA environment, to get best performance, it is essential that every data slice performs same amount of work when executing a query. Because a query completes only when all the data slice completed its part of the work. Therefore, a distribution method that distributes data evenly across all data slices is the single most important factor that can influence overall performance. Here, the ncds command shows how much storage space is used by each data slices. The data slice 3 shows it full or overused than other slices, which indicate a storage skew on that data slice. You need to consider distribute data evenly across all data slices. It is possible one of the table involved in the slow query having storage skew. You can gather information about a storage skew using ng-skew command. The top of the ng-skew command will show the overall SPU disk utilization, but that's not the part you are looking here. The bottom section of the ng-skew command output will list all tables on the system in which the largest data slice has 100 MB more disk usage than the smallest one. The 100 MB value is the default, but that can be override. Try to find out which table has the highest min max skew value and focused on large table only in terms of size. The skew ratio is expressed as a range. At the low end, it could be 0.00, which indicates one of the data slice stores no data on the table. Consider choose a better distribution key so data evenly distributed across all data slices. Are you running into any processing skew? Processing skew is introduced during query execution. Typically, it occurred due to data redistribution. To detect processing skew, you need to monitor the SPU swap space usage while executing the queries. The NZ spoo swap space command provides a summary of swap space usage for individual spoos. It also shows swap space used by each individual plan. In this example, the plan 122 is highly skewed. Just like the previous slide, skew ratio and swap space used, it can help you to identify a processing skew. To fix this type of issue, you need to focus on optimizer to broadcast smaller table rather than to redistribute a bigger table and cause possible skew. There are two optimizer parameters: enable factorial planner and enable size threshold can help you to prevent broadcast a fact table. A performance problem can occur because of WLM settings or wrong usage of resource group. NZSQA SCADQ is the main command to find out any issues with WLM. Here is a scenario where all of a sudden jobs running slow due to WLM problem. A common user practice is run jobs from admin group. Admin resource group is a special group and none of the scheduler restriction apply to this group. In this scenario, jobs from the admin groups taking up most of the resource that causing public group to suffer. This issue can be fixed by assigning 100% resource to the public group, but it's always better not to run or not to use admin group for daily operation. Optimizer uses statistics to make decision on best execution plan. The most reliable and up-to-date statistics are, the more accurate the optimizer's decisions are likely to be. But do you really need to update statistics? You can use the nzGenStats command with info option on a specific database or on an individual table to confirm if a generate statistics is needed. Check the informational column about the required generate statistics command that you need to run to improve the performance. Do you have a huge catalog? Every query have to go through the catalog operation. If the catalog on the host is large, query against the catalog and connection to the database will be slow. Run the NZ catalog size to find out the details of the current catalog size and if vacuuming will help you to reduce the catalog size. It may not be cause of the current performance problem, but it is one of the important aspects to check. If the catalog size is more than 4 GB and database flags for reindex, you need to consider a manual vacuum. Is there any table used by the slow query that was altered but not groomed? PDA allows to have multiple version tables, but these are internally treated as views. When you query such tables, Optimizer will generate plans against views, and depending on the operation, you may end up with a bad plan. Use nz alter table script to find out any version table exists on your system. If there is a version table, consider to run groom table table name version to get rid of any version table. Do you have a big difference between stable and last transaction IDs? Depending on the nature, it can be cause variety of problem, including slow processing at DBoss level, transaction taking long time to commit, etc. Lot of internal operations such as groom, backup, restores are based on the stable transaction ID. And at times, you might have an open transaction for days that can cause performance problem. Use the nz transaction command to find out the difference between the stable and the last transaction. Typically, if the difference is higher than 20,000, you can run into a performance issue. Look for the old transaction and investigate why it's running for long. Sometimes a query itself having problem that cause it to run slow. Mostly you will see this kind of problem with a newly developed query. Use nzplan to analyze the query plan. It displayed contents of the slow plan file along with many other additional piece of information. Analyze a plan file is complex, time-consuming factor and need good knowledge on the query. However, you can quickly look for some red flags. Those may cause possible performance problem. In NPS, has join is the optimal join option. Other type of joins not necessarily always bad, but those can cause slow performance. Check things to note section to see any disk-based join, cross join, or expression join used. You need to review the query logic. A query rewrite or in some cases use of specific optimizer parameters can help. Secondly, if there is a in clause used in the query with more than 5 values, optimizer will create a temporary table and join it. Joining table is always a costly operation. You can use the enlist threshold optimizer parameter to influence optimizer to use or expression internally rather create a temporary table. With or expression, FPGA can eliminate rows more efficiently. Next, see if optimizer broadcasting right tables. If factorial parameters not set correctly or statistics not up to date, optimizer may broadcast a large table which eventually cause performance problem. Check the table summary section in NZ plan output to verify which table broadcast or redistributed. Consider optimizer parameters like factorial planner or factorial size threshold to help with this kind of situation. How can you determine if there is any slow disk that may causing the problem? The NZ responders command shows response of running query plan across each data slice. You need to identify the response of your query in this output. In case of a problem with disk, query will be running state for a long period. In general, if nzResponder constantly show a particular data slice for one or more queries, you encountering performance issue that indicate there could be some problem with the data slice. In this example, plan 83 running update that used to take a few seconds to complete, but now things are taking way longer. The data slice column lists individual data slice number, those still running query snippets. Here, the update statement running constantly only on one data slice, which is 13. Typically, I/O operation is fast, but if nzResponder shows any running query busy on certain data slice for a long time, it indicates something may be wrong with the data slice or disk. Alternatively, a data skewing can shows similar kind of behavior. So before conclude, it's a slow disk, confirm query is not causing any data skew. To confirm any underlying disk issue, run the NZ check disk scan speed during light activity along with NZ responders for further investigation. You can also use the disk smart option with NZ's push command to see disk status and any read-write error with that specific disk. You can use the nzResponder script to check if a SPU might having issues. Use the SPU parameter to show the SPU and associated data slides that struggling. Just like previous slide, if you see same SPU keep showing up in this output, it indicates a particular SPU is running slow compared to other SPUs. In this example, you can see SPU with hardware ID 1162 is keep coming up, which can be a problem. Before you make conclusion, confirm there is no data skew is occurring. There are many different components inside a SPU. You should work with IBM support team for further analysis on SPU issue. You can run into general slowness and performance degradation if any network interface constantly dropping packet during data transfer. Use the ifconfig command to verify if packet dropped continuously. It may possible RX and TX shows large number of drop packet, but it is not necessarily is happening currently. So before conclude it's a network or adapter issue with a particular network interface, make sure drop packet currently happening. Once identify the issue with packet dropped on a particular interface, you need to get more information about the specific interface using the eth_tool command for further investigation. Here is few tools for collecting diagnostic data. You can use the monitor.sh script to collect the required diagnostic information for performance problem. Monitor script can be used for different other purpose. For performance issue, make sure you use the performance and archive plan argument when collecting data. Use a cron job to run this script continuously in an interval whenever performance issue occur. You can look for the data log along with the plan files for the particular time frame. The monitor.sh script is the first choice for collect data to analyze performance issue. But if monitor script is not running during the problem, you will still use nz log collector tool with nps hang or spoo hang option to collect diagnostics data depend on the scenario, which may not reveal the problem. Remember, nz log collector is not the substitute of monitor.sh script for analyzing performance problem, but it's better than having nothing. Hope this will help you to analyze query performance issue next time. Thank you for watching. Goodbye.